In this video, we will be discussing the properties of parallel and perpendicular lines. So let's first take a look at these two lines over here, which are parallel. Okay, so let's see what are some of the property that makes them the parallel lines. So, but to do that, let's look at their gradient. So let's first find the gradient of this first line over here. Okay, so recall the gradient is given by the rise over run. Okay, so what we can do is to look at this red triangle over here. So we can see that the rise is 0.8 and the run, right, is, which is the x, the change in the x is the 1 units. So the rise over run, the gradient, will be 0.8. So similarly, let's look at the gradient of the second line. So again, we can look at this red triangle over here. The rise is 0.8 and the run is 1. So once again, I get a gradient of 0.8. So what do you notice about the two gradients? Okay, so turns out that the gradient of the parallel lines, they are equal. Okay, so in this example, they are equal. So let's take a look at another example. Okay, so another example is over here. So once again, we have two parallel lines. Okay, so let's once again try to find the gradient of each line. So the gradient for the first line over here, once again, we are taking the rise over the run. Okay, so in this case, it's a sloping downwards. The line is sloping downwards. So the rise is negative 2 units. Okay, the run is over here. Okay, same 1 unit. So we get rise negative 2 over 1 to be negative 2. So let's take a look at the other line over here. So gradient will be, so we'll look at this triangle over here. So once again, the rise, right, is negative 2. Okay, and the run again is 1 unit. So we get negative 2. Okay, so we do observe that once again, for these two lines that are parallel, their gradients are the same, right? Same gradient. Negative 2 here, negative 2 here. Okay, so let's take a look at your notes. So given you have two lines L1 and L2, okay, so you have two lines L1 and L2, and they have the gradients M1 and M2 respectively. So L1 has gradient M1 and L2 have the gradient M2. Okay, so just now by taking a look at two examples, we can see that when they are parallel, right, to each other, okay, and the symbol we use this one, right, two lines over here, right, this symbol we use for parallel. Okay, if and only if they have the same gradients. So what does it mean? It means that if the gradient for L1 is M1, the gradient for L2 is M2. Okay, having the same gradient means M1 must be equals to M2. Okay, so this is the property of parallel line. They have the same gradient. Okay, now let's take a look at perpendicular lines now. Okay, so this is the first example. Okay, what does perpendicular line mean? Well, it means that when they intersect at right angle. They intersect at, okay, the angle between them is a right angle. So these are called perpendicular line. Okay, so let's once again we try to find their gradients. Okay, so for the red line, okay, we call it line A. Okay, the gradient is given to be 2 over 3. So how do we get the gradient? Right, how do I get the gradient? Right, it's rise over run, so it's 0.67 over 1, which is 0.67. Okay, but in this case, the 0.67 is an approximation, so it's actually equals to 2/3. Okay, and that's why we get over here. So for the gradient of the second line, the blue line, okay, so for the blue line, we look at this blue triangle over here. Okay, the run is what, the rise is negative, right? So it's sloping downwards, negative 1.5 over 1. So you can simplify it to negative 3 over 2. Okay, so the first line has gradient 2/3. The second line has gradient negative 3 over 2. What do you observe? What is the relationship between them? Okay, so what we can try to do is that let's try to multiply them together. All right, so the gradient of line A, okay, so let's do that. Let's do this. Let's call this first gradient the slope of gradient of line A, we call it MA. Okay, so the slope of gradient of line B, we call it MB. So let's try to do MA multiplied by MB. So we have 2/3 the gradient of the first of the line A multiplied by negative 3 over 2 the gradient of the line B. So what happened is, oh, quite nice, things seems to cancel out, leaving negative 1. Okay, so when we multiply the two gradients, you get the answer negative 1. Okay, let's see whether this is true for another example. Okay, so this is another example over here. So similarly, we have line A and line B. Okay, so let's do it faster this time. So since the picture already gives us the gradient, okay, so let's call this, right, gradient of A, right, MA. Call this gradient of B, MB. So let's try to multiply them again. Okay, you get negative half times 2. What do you get? Once again, you get negative 1. Okay, so if you look at this example, when you multiply the two gradients together, you get negative 1. In this first example, when you multiply the two gradients together, you also get negative 1. Okay, so this is the property of perpendicular lines, right? So L1 is perpendicular, right? The symbol that we use is over here, right? So something like that. To L2, how do we know that they are perpendicular? If and only if the product means multiply or times. The product of their gradients is, so what do we observe just now? Okay, is negative 1. Okay, so you can think of it as M1 times M2 is negative 1, or if you make M1 the subject, okay, you can divide the M2 over, you get negative 1 over M2. Okay, so this is the property of perpendicular lines, right? Looking at the gradient, the product of their gradients is negative 1. Okay, so you may want to watch this video over here, okay, which gives quite a simple proof on why the product of perpendicular, the gradient of perpendicular lines will always be negative 1.